Hello guys, welcome to my YouTube channel. So today we are going to solve weekly contest problem number 2 to 64, which is count number of nodes equal to average subtree. So we are given a root of a binary tree and the number of nodes. Okay, number of nodes where okay return the number of nodes. So we have to return counts of number of nodes where the value of node is equal to average of its subtree. Now the meaning of average is like sum of nodes and divided by number of nodes. Okay, sum of value of nodes and okay. Now subtree is defined like root plus c consists of roots and all its descendants. So root is also included. Like they are not saying like four and eight and five. We are not. We are going to include four also. Four and all its subtrees. So okay, so let's go through example. So here, like see, if we consider root, then the sum of root and all its subtree is like 24, and divided number of nodes are 6. So we get 4, which is equals to the value of node, which is 4. So we calculate 1. So similarly 5 also satisfy, and leaf node will always going to satisfy this condition, since divided by 1 will give its the number itself. So yeah, so three nodes and four and five. Eight doesn't satisfy. So like for like the summation of the root node eight is like nine, and the number of nodes are three, which is equals to average is three, but the node value is eight, so it doesn't satisfy. Okay, so now let's start with the problem. So like okay, we are so in LeetCode this function is already implemented in JavaScript. So tree node. So we don't have to implement this. So it is already given in background. So like we are given a root which is of type tree node, and tree node contains value left and right. Okay, left is again subtree of like tree node, and right is also of type tree node. So it is like nested. Okay, it can be null or undefined, and otherwise it can be like of tree node. Okay, so yeah, let's start, and we have to return the number which is number of nodes. Okay, so see, like if we look into this problem, so see, it is like it is breakable into sub problem. If we go to root, then root can be divided into two subtrees like left and right, and again this can be divided into left and right. Okay, so if we solve this if we do depth for search, if we solve this bottom, then we go up, then we solve this, then we go up, then we solve this. Okay, so okay, so to solve bottom, we need left and right. To solve this left, we need left and right of this node. And to solve this, we need left and right of this node. So since left is null, so we don't need to calculate. So yeah. Now okay, so let's define a skeleton. Like we need like count for answer, and we need a one function like BFS, which is going to take a no root, and okay, and we are going to return a count. Okay, okay. We can consider this as a node, so let's not confuse it. Okay, now see, okay, now see, what we should return from this DFS. See, what we are going to need, we are going to need for this 4, we are going to need sum of this node and sum of this left and right nodes, and number of nodes in the left and right, to calculate the average of this. Okay, we cannot return average, so we cannot calculate the average of this node if we know average of right and right, left and right. Okay, we need both numbers and sum and numbers of nodes. Okay, to calculate properly. Okay, okay, so let's try. So this is going to return like two values. So two values we can return in array, like if we now want to return two nodes. So first is going to be sum of left plus right plus node value. Okay, node value itself, current node value, and like so left sum of values. Okay, values of nodes, and it is going to be sum of number of nodes, sum of number of nodes in left plus right plus 1. We are going to add a plus 1 since this current node count as a one node. Okay, so yeah, okay, now let's write a base condition like when we should halt. So in tree, the base condition is always like if node is equals to null. Okay, if node is run, then we are going to return like sum is 0, and the number of node is also 0. Okay, Okay. Now, since see, to calculate this, to calculate the average of 4, we need first left and right sum, like number of nodes and number of sum of values. Okay, left and right. So okay. So let's calculate left goes to DFS nums no node dot left, and let's calculate right. Right is equals to DFS node dot right. Okay. So now we have left and right. Since it is, see, this DFS is going to return two values, so we can use destructuring. So like we can shorten the code. Like we can write over. So let's write over here. So let's write like first value will be sum left sum and left number. Okay, number of nodes. So it is going to be left. Okay, and let's write like r sum and r node. Okay, r num. Okay, so it is going to be right. So this is latest ES6 syntax, like destructuring into array, destructuring of array. So yeah, so now let's calculate the average. Okay, let's calculate first sum. So let sum is going to be left sum plus right sum plus node value. Since in left and right it doesn't contain this current node value. Okay, okay. Let's calculate number of nodes. So like uh, L num plus R num plus 1. Since we are including 1, like this current node should also be included. Number of nodes in the left, number of nodes in the right, and the current node. Okay. Now let's calculate the average. Let's average is going to be like math. Okay, let's calculate sum divided by number. Okay, and since it can be integer, so like we can, it can be like floating value, we can convert it into, like we can convert it into integer by doing math dot floor. Okay, that's okay. So yeah, so now we can check if average is equals to count. Okay, now average is equals to node dot value, not count. Okay, okay, then we are going to, then this node condition satisfy the condition, we are going to increment it. Okay, okay, now all the conditions are, all the things are done. Now only thing is like we have to return from over here, since everything should return. Okay, every function call should return. So now we are going to return like sum and number. Okay, we which we have calculated over here. So this is the sum for current node, and this is the sum number of nodes for current. Okay, now the only thing is remaining, like we have to call this DFS with root node. Okay, okay. So yeah, so let's try to run this code. So yeah, it gives the correct answer 5. Let's try to submit it. So it is accepted. Thank you guys.